Montessori Method in the young child. I guess I just want to start by saying I woke up this morning and reached down, turned my radio on, and I heard this gentleman being interviewed whose name was John Fong, and he's a Harvard graduate and an MIT graduate, and he's been working at MIT ever since. And he was talking about having immigrated to the United States as a child of 11 to Iowa. And being a scientist, as a young child, he was taken with the natural world. Everything about it interested him. And this led him to become highly educated in the sciences. And he was an integral part of the CRISPR, which is the genome sequencing and helping to target different diseases through the RNA, the ribonucleic acid entry port. So the reason I'm bringing him up at all is that the way he spoke of his wonder about the world around him has never stopped. And all of his teachers said, my gosh, he was unstoppable because he wanted to know what was under the rock. Why was it under the rock? How long had it been under the rock? And he asked all these questions about minutiae and things that a lot of people didn't even notice anymore, even as a young man. And this carried him through his scientific studies. And I feel very strongly that with the Montessori Method and science and all the other curriculum that we use, this is such a part of the child's learning experience here, is their wonder and their questioning. And we as educators don't shut them down. We try to meet them where they are at all times. And if we don't have the answer to their direct question, we have no problem saying, you know what, I don't know the answer to that, but I'd be happy to look it up and get back to you. And oftentimes we're able to do it in the moment with our iPad or our phone, and we can look at something right away to bring that knowledge to the child in their immediate interest. So I feel that's such an important part of the Montessori education is that we really try to meet them literally where they are at that moment. So with that in mind, you may know some of these materials. This is the pink tower, which is very famous, and the brown stair, and these are in the classrooms in the lower childhood classes. And at first, when the child is introduced, it's a very scientific lesson. They sit beside the teacher and they're presented the material is named, and they learn how to move one piece at a time, and it's a very exacting moment for the child. And oftentimes they sit there and watch, and they might ask a question, but not too much. And then the second lesson, you might give them more language, and they are involved in manipulating the work, and then you pretty much leave them to it. And so if you step back and watch what they do with it, it's fascinating because they will discover on their own all about levers, all about gravity, all about ramps, all about push and pull with their friends that they're working with. And they use it in such unbelievably different ways. And it doesn't matter if it's one child working with it or two. So sometimes after they've been working with the work for quite some time, I try to introduce more into the moment with them, and we sit down and I say, okay, you build a tower, whatever you want, using the brown stair and the pink tower together. See what you come up with. And they finish their work. And I'll say, okay, let's record that. Let's observe that. So I show them how to take out a clipboard. I give them the appropriate colored crayons, and they start to work. And it's amazing. I mean, these are recordings that they did on their own after having built something. So this is a brown stair and pink tower that Andy saw, and this is what she recorded. And we talk about what we see is what we record. So you're looking at your work. You're not looking at your friends that might be near your work. So you're not going to draw your friends in your work because they're not what you're observing right now. So Andy really understood that and honed in on her work. Rena, the same thing. And then she came over and tapped me on the shoulder and she said, but I see something else. And I said, oh, what else do you see? And she said, I need a blue crayon. I said, okay. And then of course I looked at her rug, and her rug was blue. So that brought another element that she reminded me. I need another color to record properly because this whole work rests on a blue rug. So as they hone those skills of observation and are able to translate them onto a piece of paper, we move along in the classroom. I always have nature out on a table, like these beautiful pine cones and petrified wood and rocks, something they can sit down at a one-person table, with paper and with the appropriate crayons, and they can observe what they see and record that, and that changes. Sometimes they bring things in from outside that have appealed to them and add it to the table, and children come around and watch to see what each person is doing. And I always have work out on the shelves. So this is a magnet work. These are the magnetic balls and a huge magnet with a keeper, so it stays magnetized. And it's fun to see them put the marbles on the blue tray and then put the magnet underneath the tray and manipulate the marbles. And I haven't shown them that. I showed them just how to use the material in the very most basic way, so it opens up their chances and gives them time to explore it on their own. And as long as they're treating the work with respect and are being mindful of it and are readying it for a friend when they're done and making it presentable on the tray, that's all they need to do. And they're very, very good at doing that. They get that lesson right away. So over here is another observation that we did on our table. Majewski, the woman I teach with, brought this beautiful display in, and I hung it on the wall at our science table, and the children came over and oohed and awed and wanted to record. So this is just visually looking at each of the butterflies, choosing one and recording it. So Annie's first one, she did the butterfly and then noticed, oh, it has a name. So she copied the name as well. And then this is another example of her work. I no longer have this creature in the classroom, but I had a guinea pig named Peaches for 6 years, who was beloved, and we had a book out, so I just thought I'd bring that as well, because I just love this rendition. It's such a happy critter. And some of the children, being young, 3, will come and just scribble, but that's okay, because this is the beginning of the process for them. As you know, the sensorial materials, which is what the brown stair and pink tower are also a part of, we have these little special bags, and the child will place a bag over their head, and they take these beautiful natural blocks and they place them in the bag. It's like a little pouch. So I have 8 blocks in here, and so they place all 8 inside. Now, the only thing they're able to use at this point is their sense of touch. So they will draw out one shape and look at it, and we'll name it. That's a rectangular prism. And they set it on their rock. And then you have to think that there are 8 sets in here. They'll go in, and they really have to feel it, because there are lots of different shapes, and lots of the shapes have angles and flat surfaces. So their mind is picturing what their hands are feeling and giving them a mental picture, which carries over into all the other areas of the classroom: writing, mathematics, geography. And then they say, oh, I think this is it. And they've made a match. So they love to do that by themselves, and I often put 2 bags on, and children can take turns matching. So a friend gets to choose the initial block, and then their friend has to reach in their bag and find the matching one. So this is all sensitizing the senses, which are so important in the Montessori classroom and in life in general, that we hone all of our senses. This is a work that we've done with the kindergarten program. So we've been working on ramps. So we set up 3 separate ramps. I'm just showing one example here, but they were of varying heights. So very high, medium, and then very low. And we placed a ramp on it. And then we used a weighted beanbag. And everybody had the same equipment, and they tried to see how far that ramp would carry that beanbag. So the results would be something like this. The ramp would be set up so that the end of the ramp, the very bottom bit, we drew a line. And the child held the beanbag at the top of the ramp, released it, and it would slide down, and it would land somewhere off the ramp, which was then recorded with their initials. And they had some varying results, but it's within a spectrum here. So we did that with each of the heights, and the children discovered, well, they thought the incline that was the steepest would have the furthest, the beanbag would go the furthest. And that was not the case, because it was at such an angle that it stopped short, almost at the very bottom of the ramp. So that confounded them at first, because it didn't make logical sense looking at it. They thought, oh, well, it's so steep, it's just gonna go across the room. So these types of experiments for them is wonderful because it's hands-on, they get to see it, they get to do it, they get to record. Very important for them in the process of the scientific method. For the program, we touched on matter and the 3 major states of matter. We touched on plasma, but we didn't go into it because it's not something that they would encounter in their everyday life, but certainly liquids, solids, and gases. And we talked all about their properties and did many, many experiments using those different things. So I thought I'd just run through a little bit of what we touched on this year. We're not quite finished, but we did the properties of solids and things like rough and smooth, large and small, which again, many of these things are also done within the classroom with the sensorial materials on a daily basis. Many of us cook with the children, which is science again with measurement and how different matter changes state by adding heat or taking heat away. And it's right throughout the classroom. I've really enjoyed it because the children have so much wonder and so many questions, and this is a place where they can take off with it and ask more questions. Well, what if we changed one property? So if you drop a ball in a big tub of flour to create a crater, and the flour puffs up and then you've made this crater, well, what if you changed the flour? What if we put sand in there? Oh, well, let's find out. So we bring sand in and we put that in the tub and we drop the same ball. Well, what happened? Oh, okay, so the force was absorbed more by the sand and it didn't make quite the same dent as the flour, and you certainly didn't get that marvelous puff. So different aspects of the curriculum allow itself to be drawn into the scientific inquiry, which is so important to the young child. One of the lessons that we did upstairs, which was really fun, because as I mentioned earlier, a lot of the children were drawing not only the experiment, but background things, and that's not what we were trying to get them to do. We wanted them to hone in on the experiment. So one day, Andrew and myself were upstairs in the science room with the kindergartners, and we said, we're going to do something a little different today. So Andrew and I faced one another in a chair, and we each had a piece of paper and an assortment of markers. And I said, I'm going to observe Andrew, and I'm going to draw Andrew. So the children watched, and I said, at the same time, Andrew's going to draw me. So these were our results. So the idea was, I drew Andrew sitting in a chair with his recording board in front of him, and he drew me also recording. But there's nothing else in here. We were the experiment. You can't see the wall hangings, you can't see the children sitting down, the tables, chairs, the lights, anything else, no distractions. So after that, we paired the children up and we had them draw one another. So this is Gabriel, he drew Evie, and Evie drew Gabriel.
Very sweet.
And I could go on and on through all these parents. You're welcome to look through them afterwards. I'll show you another one. This was another one. So these children, to explain why they are legless, their legs were under a table and they were sitting across from each other. So they could not see each other's legs. Wow. And they were not allowed to imagine them because that's not an observation. They had to draw what they saw.
This is kindergarten.
This is kindergarten, yeah. And we've had a terrific class. Emily and I, many times after class is over, will sidle up to each other and say, wow, did you hear that question? Oh, I know, never thought about that. You know, and so they come up with these great ideas and they take away, and we hear them as we come down the stairwell, because this takes place upstairs, talking as they're coming down. And it's right near dismissal time, so if they see a parent or whomever's picking them up, they might run over and say, we did. And they'll go through the whole experiment, bang, 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 bang. I'm like, wow, they completely took it in. And I've enjoyed this year, especially with Emily, because she's a very organized, routinized person. I'm a little less routinized than she. So I think that's been a tremendous benefit for the children. So we come up and there's a real set routine. The children come to the door, Emily is at the circle, she's drawn on the floor, and they enter the room, and then she invites them when they're ready. So they have to be composed. and then she'll say, oh, please come to the circle and sit down. So they come and find a place, and they each find a place. Then, if there's any kind of niggling going on or chatting, she'll say, oh, John, would you please trade places with Anna? Oh, thank you. So that quiets everybody down. She's like, oh, well, that's the end of that. And then we have this wonderful presentation that Emily will give. And then the children are set up at a table. We each had a group, myself, Emily, and Andrew, each had a group of children that we've had for the whole year. So all the materials are placed on the table beforehand, the recording papers. And the children all sit at their places and they chit-chat a little bit, but they know what the expectation is. And they go ahead and perform their experiment on their own and record all of their findings. So this is Gabriel Okeki. So at the very beginning of the year, we were studying matter, and this was just rough and smooth. So this is what rough and smooth was like for Gabriel. And as you can see, there's no background noise going on, as it were. It's just what he saw. And then we studied liquids the following week, and then all of a sudden his classmates were there. There was the liquid. So that was accounted for. Then we did a mixing of solids and liquids. We added tiny pieces of apple to water to see what would happen. If I add that solid to a liquid, will it stay a solid? Is it going to dissolve? Will it change shape? What's going to happen? So they discovered that it just stayed a solid within that liquid. And then we did solids and liquid mixed again. So that was another solid we used. And then we moved on to gases. So all along here, Gabriel is recording his work, and at the end of it, he stamps it with a little stamp. And this was gas and liquid. So we pumped with a bicycle air pump the air into a glass of water to see what would happen. And we talked about how the gas is lighter than the liquid and escaped. And they loved that. And then the density of liquids, so we made sort of a cocktail of corn syrup, water, and oil to see what would happen, and it layered, and they thought that was amazing. And density of liquids and solids, so we put in a raisin to see what would happen to that raisin. Is it going to stay at the top? Is it going to go partway down, or is it going to land on the bottom? So they discovered that on their own. And then the changing of a solid to a liquid. So we used ice cubes to see what would happen in hot water, in cool water, and cold water. Oh, so is it melting as fast in the cold water as it did in the hot water? Why do you think that is? And the responses, like I said, are always amazing. I mean, some of the children are so tuned in to the scientific world. And others that are very quiet, you start to wonder, are they getting something out of this? And then they do their recording, and then you overhear a conversation with a friend, and you say, oh my gosh, they completely understand it. I mean, they might not be sharing it with us directly in that moment, but they are understanding the concepts and having conversations with their peers. So this was steam changing a liquid to a gas. And then we did changing a gas to a liquid with using condensation. So we made a cloud. They loved that. And it was the perfect day. We have a bank of windows. And it was a very cloudy day, but they were puffy clouds. So I said, look outside. What do you see up in the sky? And we talked about clouds. What are they? Why are they there? What do they do? Why are some dark in the distance? What do you think that means? And so we pulled nature right outside our window into the classroom for that. So this was cloud in a jar. Now, we're starting to get a lot of friends in the picture, and I think it was about this time that we did that little study of just record exactly what you're studying and looking at and be precise and no background noise. And so then you can see a shift here. When we did solution and evaporation making crystals, he's just got the experiment. So the children really took that exercise to heart, and it was a lot of fun. And I have another example up here of another child's work, Bree Walgreen. So I just have two of the many examples where we have 24 children in the program this year. And It's been terrific, and I couldn't have had a better partner with Emily. Like I said, she really keeps us on track and doesn't let us deviate, and she has a wonderful, wonderful way with the children. I've learned a great deal from her. And of course, Andrew has been a wonderful presence, very quiet and calm, and he knows exactly how to maneuver around a circle and just puts a gentle hand on a child to bring their attention back to what's in front of them. So it's been a marvelous experience. I feel very blessed to have had this time with these two colleagues of mine. And that's where I will end, but I certainly am happy to take questions if you have any.
So was this the first year that the kids were pulled for the science in the kindergarten program, or is this the regular?
This has been going on for several years now. I can't quite remember when I started. I think it's been 5 or 6 years. Joe might have been one of my first students from upstairs, Joe Schirkenbach, but I can't remember precisely. The years are starting to blend. Any other questions or, yes?
Another question I want to ask.
Yes.
Drawings, they were illustrating?
Yes.
Did you draw it or they just did it from what they're observing? Did
They
you draw
were-
it on the board for them?
No,
Oh.
no. That it was just myself and Andrew sitting across from one another, and we drew each other in that moment.
No, not that.
Oh, I apologize.
When you are giving, like the illustrations you gave, the drawing, when you are giving lessons,
Yes.
did you have a board that you draw when they see, or you just explain and
Yes.
give lessons and they will draw it from their imagination?
Well, they have the experiment is still set up,
Yes.
so they can refer to it, but it's the one that they've done that they're drawing from. So they're recording what they're seeing, what they have done.
Okay.
What happened to the raisin?
What happened? Do you know?
No, I don't, that's why I asked.
It sunk all the way down.
Did it go all the way down?
Yeah,
Sloppy.
yeah.
Sorry, I don't.
That's okay.
We know what Brandon's going to be doing this
And
weekend.
and I didn't know what that word, I learned a new word today too, but thank you. It was very informative, I
Oh.
appreciate it.
Thank you.
Meg, you're working with the kindergartners for Science Fair?
Yes, we are indeed.
That's next week, right?
Yes, and I think, actually, I'm not gonna commit to the topic because Emily's taking the lead on that, and I will follow her lead. But it should be wonderful, and I hope all of you can come. It's very exciting, the time. The children just love to go up there. So if you're able to get away to bring your child up and walk through with them, that means an awful lot to them because they're very excited to show you what they've done, but they also want to see what the older children have been working on. So it's a great time to introduce them to what's coming. Because this is just the beginning, you know, and as we go through, it's a marvelous program.
Yeah, it is.
When's that? I'm sorry.
When?
When?
It's May 4th?
Friday the
May-
4th,
the
May
4th.
4th, and it starts right at 8:30 in the morning, up in the middle school area. And the kindergartners all the way up to the 8th graders will be presenting. Some children do their projects at school in the science lab with the science teacher with Victor, and lower L does their projects at home with their parents after discussing what they'll be doing in the classroom and working on the scientific method in the classroom. So there's some group projects, some solo projects, some homework, and some schoolwork, all in one. It's great.
Yeah, I remember doing it with my older son, and we had a gerbil at the time. Who hasn't had a gerbil? And he wanted to make a habit trail, but he used toilet paper rolls and all these different things and had to tie them together. And of course, the critter kept escaping. So that was a lesson in itself that you have to be very meticulous in how you join up your different parts of your experiment so your critter doesn't escape. And I think it left a lasting impression on him. He also went to Destination Imagination, which a group this year also went to, and he got a lot out of that.
I think you do in the children's house and the kindergarten such a fantastic job of the building blocks of what the scientific method means to the children, because we really hammer that home from grades 1 through 8 that when it comes time for science fair, it isn't about going to the library or going onto Amazon and buying a book and opening up to page 67 and replicating an experiment. Here are your ingredients, here is the procedure, this is what you're doing. Is very much coming up with a question on your own. Sometimes a very easy question like, which type of dog treat will my dog prefer? And then coming up with your hypothesis and then testing it and designing your own experiment. So with some of the younger children at lower L, the experiment isn't incredibly scientific in the word that you would really think of. Things might not be exploding and whatnot, but it's them coming up with a question and going through the whole scientific method to design an experiment, test their hypothesis, record their data, and then record their findings, which makes it 10 times better in my mind. It's really them designing the experiment and figuring out how to answer their own scientific question.
Yeah.
And so the breadth and scope of what you're seeing is completely from their own minds, not just, like I said, copying an experiment from a book. It's really wonderful. And it all starts with what you're doing on here.
Yeah. But the scientific method in a way is throughout the classroom at all times. I mean, you can, even reading comprehension, if you think about it, is based on the scientific method, because you're asking the child, well, look at the cover of the book. What do you think that's telling you? Oh, it's about a girl and her dog. Okay, so what do you think happens? Oh, and so you go through actually the scientific method when you're teaching comprehension in reading. It's the same type of give and take, questioning, finding out, was your hypothesis or prediction correct? Oh, no, actually, it went off on a tangent. So it's everywhere. It's embedded in the curriculum all the time. And the lessons presented are often based on, you know, a 3-period lesson, and they have to name and they have to think about it. And even when they're building with something as simple as these sets of prisms, they try to invert it. So they'll start with the smallest pink cube, and they'll start to balance the next size cube, and they go up, and then eventually that does not work because the base isn't sturdy enough to hold your tower. But that's science, and what's going to happen? Well, you can predict because of gravity it's going to fall, but at what point will it fall? After the 3rd cube or after the 5th cube? And then they do almost very, not simple levers, but cantilevers. So when they build at the brown stair, they'll have one of the brown stairs will jut out, and they figure out just how far they can go before gravity takes over. And how can you stabilize it? Oh, well, if I place another block right on top of it, I can have that go out even further. So, and this is, the teachers are watching this out of the corner of our eye, because the whole idea is to stand back and let the child discover these things for themselves. And we might never directly comment on what they're doing, but we've made a mental note so that when we circle back with that particular work or with something else that's interesting to them, we'll pull that out of our heads and say, oh, okay, let's just see if we did this. And we have conversations with the children where they're responding to our inquiry, you know, with their own minds and with what they've already done. Anybody else? Any other questions? Or? All right, well, thank you so much for coming. I know many of you have work you have to get to, so we appreciate you making the effort to come this morning.
Thank you so much.
Thank you.